Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we're going to do 7 problems of practicing two-column proofs with angles. So if you're looking at big ideas, this correlates to chapter 2.5, 2.6, 2.4, that area. And this is the real beginning of actual proofs in geometry. So this is something that you're going to come back to over and over and over again. So in the very beginning, if you're in a place where you're like, I don't know that I can do this, don't worry, fear not. The more problems you do like this, the better you're going to become at it. And so just don't give up, okay? Another recommendation that I have is for you to really go in and remember the postulates and the theorems and when to use them and how to use them. It's going to be super helpful with that. Okay, so I'm going to go ahead, I'm going to share my screen to one of these sets of problems. And another thing that we're going to do is we're going to actually go through this problem set, and I'm going to maybe take notes in the center or somewhere on the sides. Just make sure that you're keeping tabs on what's happening at all times. Okay, so the very first thing that we want to do is when we are looking at a proof, we take a look at the given information. That's usually going to be the very first thing that we're going to state in the statements. But before we get to any of the statements or reasons, the very, very first thing that we want to look at is the diagram and the given information, and go ahead and tick mark that. So I'm told that the measurement of angle 1 and the measurement of angle 2 are congruent. So I'm just going to tick mark those two in red. You can, for purposes of ease and just, I guess, ease, just use a pencil. Don't worry about it. It's going to be totally fine. Or you can get all fancy and use different colors. I'm going to use different colors just to make sure that I can see things a little bit differently, a little bit clearly. So angle 3 and angle 4 are also congruent, so I'm going to give those their own color as well. And what I'm going to do in here is I'm going to say the measure of angle 1 equals the measure of angle 2, and the measure of angle 3 equals the measure of angle 4. And this information is given. Oops. So if we take a look at the second set of information, we're looking at 1 and 3 are being added. So 1 and 3 here is being added to 1 and 3 here, right? Those two are being added, and these two angles are being added, and we're told that they're equal. So on the one hand, I want to say that we are doing some sort of angle addition postulate. However, when I look down here, I do see that measure of angle 1 plus measure of angle 3 equals BAC. So here's BAC, and here's, this whole big angle. I would say that this is closer to the angle addition postulate, because we are being told that certain angles added together equal this larger angle, right? In here, as I was looking and as I was thinking about it, I was thinking this is more of addition property of equality. Some teachers write addition po, whatever. And then the last piece of information that we're told, so we know, for example, that this angle is one whole big angle, this angle is another whole big angle. We want to go in and we want to say the thing that we're trying to prove, right? We're trying to prove this angle A and this angle B are congruent. So we're going to go in, or I guess equal. And we're going to say measure of angle BAC is equal to the measure of angle ABC. And the reason why that is that this is the substitution property. So we are replacing this 1 plus 3, if you notice how it's here as well, with this angle, and we are replacing this 2 plus 4 with this angle. So that's what makes this the substitution property. Whoops, substitution property. I feel like that's spelled incorrectly. Okay. Let's go ahead and let's move on to the next statement. So in the next one, we are told that 1 and 3 are supplementary, that we are told that when we add those two angles, we get 180 degrees. I don't know that there's a real way to really tick mark this. except for knowing like, hey, these two add up to 180. So you kind of make some sort of marking so that you're clear on what happens, okay? So then we go in, oh, I did not want black, I wanted black, but okay. So measure of angle 1 plus measure of angle 3 is 180. And we know that this is given information. The second statement they're telling us is that if we add these two angles here, we're going to get 180 degrees. And we know that when we have two angles that are kind of on the same line, like these two are, they form a linear pair. So this would be, the reason for this would be the definition of a linear pair. The definition of a linear pair. Then we're being told that 1 plus 3 and 2 plus 3 are equal to each other. So this I would call substitution property, because if we take a look here, we've got this 2 plus 3 equals 180, and we've got this 1 plus 3 equals 180. So we're just going to swap out these 180s with this 2 and 3 on this side here. Another type, instead of substitution, we could say that this is substitution property. We could say that this is maybe the transitive property. That's another option. Really pay attention to what your teacher says and how they describe it. I feel like both are acceptable because you're substituting one set of information for another. Some prefer transitive property in the earlier stages. I think as you move forward in math, you'll have a lot more of this substitution property than you will transitive property. Okay, so at this stage in the game, number 4, we're told that we're going to have something that has the reflexive property of equality. So let's go ahead, let's take a look at like, hey, what are we trying to prove in here? And we're trying to prove that 1 and 2 are congruent. So that's our goal, that this guy and this guy are the same. So we already know that our last step is going to be the measure of angle 1 is equal to the measure of angle 2. One of the things that we need to state between this number 3 and number 5 is actually, if you notice, we can kind of eliminate this angle 3 and end up with our proof, right? So if I were to eliminate angle 3, I would be able to get 1 and 2. So in order for me to state that, I'm going to say that the measure of angle 3 is actually equal to the measure of angle 3. And that's reflexive property. Reflexive property means that one thing equals itself. And then in this case, we're kind of like subtracting angle 3 from this number, from step number 3 to get our final proof. So we're going to say that this is subtraction property of equality, or subtraction PO, or sub-PO, or whatnot. So that's the first set of problems from this particular handout. Okay, so now we've got this number 3, 4, and 5 on the second page of this particular worksheet. Let's go ahead, let's start taking a look at what information we have and how do we use this information in order to tick mark this first diagram. So in the very beginning, we're told that 1 and 6 are congruent, right? So we're actually going to write that angle 1 is equal to angle 6, and that is given information. We know that our goal is to actually say that 3 is supplementary to 5. So we can absolutely write that angle 3 is supplementary to angle 5. And in this case, we're kind of, told that 3 and 5 add up to 180. So we'll get to that place, but we can already fill that in. So out of all of these blank spaces, 3 of these particular pieces are super easy to fill in. We know that the first thing is always given. The last thing is always the thing that we're trying to prove. Okay. So when we take a look, we can see that angle 1 and angle 3, that is not the same line, Angle 1 and angle 3 together end up adding up to 180 degrees because they are part of a linear pair. So in this case, I would say that this is the definition of a linear pair. Okay. When we take a look at angle 6 and 3, we can say, hey, this piece of information and this piece of information, they're exactly the same. The only thing that's changed is this angle 1 and angle 6. Well, I know right here that angle 1 actually equals angle 6. So in this case, I would say I've substituted 6 in place of 1. So this would definitely be the substitution property of, just the substitution property, I guess, where we are substituting information. Once we have that 5 and 6 are congruent, we know that 5 and 6 are congruent. They're right here. These are vertical angles. So some teachers totally accept this VATC. If your teacher doesn't, you're going to write this vertical angles congruence theorem. Vertical angles congruence theorem. VATC seems to be a little bit of a popular reason for the earlier proofs in the Big Ideas textbook, okay? Now, notice that almost every single proof that we've done so far has had an equal sign, not a congruent sign. So we're going to change this congruent sign to the measure of angle 5 equals the measure of, whoops, not an equal sign, the measure of angle 6. And this is the definition of congruent angles. The other term is the congruence theorem. Congruence theorem, I've seen that. That's been pretty popular as well. Okay. So now we're told that actually not only does 1 plus 3 equal 180, but 6 plus 3 actually equals 180. And now we're being told that 5 plus 3 also equals 180 degrees. And so again, we're using this substitution piece where we are replacing angle 6 now with angle 5. So this is again the substitution property. Okay. And then now we know that 3 and 5 are supplementary with each other because they add up to 180 degrees, right? And so that's just the definition of, definition of supplementary angles. Okay, let's take a look at the next one. So it says that AD bisects CAB. So AD bisects CAB. So when something bisects, oh, whoops, I did not want that color. Okay, so when something bisects, that means we have two identical angles or two identical lengths in the line segment, right? So that's this piece of information here. We know that DB bisects CBA. So again, we know that angle 2 and 4 are congruent. One thing that you can do is use a different color in this case. Or if you're like, oh, whatever, I'm just tired of using different colors, or you're not like, that's not your thing, you can always do like a double tick, you know? So instead of just like one little half circle thing, you can do 2 half circle things. Okay, so then that's another piece of information. And then we're actually told that the measurement of angle 1 and the measurement of angle 2 are the same. So one thing that I did in my notes, and I did all of this in pencil ahead of time just to work through the problems, I just put a line straight through to state like, hey, those are the 2 angles that are congruent. In this case, I put in that AD, dang, I don't want this, it's gonna hurt my eyes. Okay, so I said AD does the bisecting, right? Also, BB does the bisecting, and your job is to actually write, bisects. Your job is to actually write this entire piece. I don't have room, so I will not do that. And then that's given. So on my end, I take up another line, but I'm assuming that if you take this entire statement and put it in there, I don't think I would have had room. In fact, I didn't have room to just write the two statements that I already did in this little box right here. So I just broke it up into two sections, into two lines. And that's what gave me the additional space, the additional line that I needed in order to finalize the proof. So don't panic if you have additional things that you need to write in. It's totally fine. It's doable. It can work. Okay. All right. So then we also want to take a look at what we want to prove, right? So we're going to say that 3 and 4 are congruent. So we're looking at 3 right here and 4 right here, and we want to state that those are congruent. So since we know that 1 and 3 are congruent and 2 and 4 are congruent, why don't we just say that information first? Okay, so, and I know that because measure of angle 1 is the same as measure of angle 3, and then measure of angle 2 is the same as measure of angle 4. And I know that because I've been told that I have something that bisects that angle, right? So that's going to be my definition of an angle bisector. Definition of the angle bisector. The next thing that I can say is the measure of angle 1 is equal to the measure of angle 2. And that's just given from right here. Then I can say that the measure of angle 1 is equal to the measure of angle 4. And the way that I can say that is because I'm told that 1 equals 2 and 2 equals 4. So then 1 must equal 4, right? And that's the way that you know that that's going to be your transitive property. So if we take a look, just to do like a quick mini lesson on what transitive property means, I'm told that measure of angle 1 is the same as measure of angle 2. I'm told that measure of angle 2 is the same as measure of angle 4. So I can conclude that measure of angle 1 is also going to be the same as measure of angle 4, because I'm kind of eliminating this measure of angle 2 business when I'm looking through this pattern. I'm eliminating that middle piece, that middle ground. This is kind of like the law of syllogism, just gives it a different name. And then the last thing that I can say is the measure of angle 3 and the measure of angle 4 are going to be the same. And I can use that as substitution from here. So that's where my last piece would come in as substitution property. Okay, let's take a look at the last one on this page. So I have angle 1 and angle 3 are congruent. That's all the information that they give us. And then they go in and they tell us that we need to say AOI, AOI. So this really large portion of this angle here is congruent to EOU. It's congruent to this portion of the angle here. So the first thing I'm going to do is I'm going to state that the measure of angle 1 is equal to the measure of angle 3, and that information is given. Okay. Then I'm going to say that I know that angle 2 is equal to itself, so that's going to be my reflexive property. So angle 2 is equal to angle 2. That's the reflexive property. Then I can go in and take this angle 2 and add it to each of the angles, both 1 and 3. However, if you remember from an earlier section in the notes, they just actually went in and added angle 3 and 4 in the very first problem as addition property of equality. Not sure why they did that, but I've always done this reflexive property business. So it's kind of like when you're trying to prove something, you're always going in and you're saying things like, you know, how do you make a peanut butter and jelly sandwich? Or how do you know, whatever the case may be, it's this whole process that you have to start at the beginning and you have to give very detailed instructions and very detailed step-by-step pieces of information in order for the person to be able to follow. So if I don't state that 2 is congruent to itself or that 2 is equal to itself, the person who you're trying to share this information with doesn't know that it is. And because they don't know, they're like, whoa, why are you adding this? That's a little weird, you know? So that's where I'm going to go in and say angle 1 plus angle 2 is equal to measure of angle 3 plus measure of angle 2. As you can tell, I've already run out of room. So this is going to be my addition property of equality. I've just added 2 of the same thing. The next thing that I want to do is I want to state that 1 plus 2 is actually going to be this AOI and 2 plus 3 is actually going to be the POU. So I'm going to use these 2 lines here, and they're going to be the same piece of information. So as I write it out, I'm sure you'll notice what these are. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle AOI, and the measure of angle 2 plus the measure of angle 3 is equal to the measure of EOU. And this is, if you guessed it, my angle addition postulate. This is when I have 2 parts of an angle that add up together to be a third, not to be a third part, sorry, to be the whole angle on its own. And at this point, this is when I can actually go in and say the measure of angle IOU is equal to the measure of angle EOU. And that's also going to be your substitution property of equality. In case you haven't noticed, substitution, sorry, not property of equality, just property, shows up very, very frequently. You're going to see it throughout your entire geometry section. It's going to just continue to show up over and over and over again, okay? So let's go into the next slide. Okay, so information that we're given so far is that 3 and 5 are supplementary. That means that they add up to 180 degrees. So the very first thing that we're always going to say is the given information, right? So angle 3 is supplementary to angle 5. And that's given. Okay. So let's take a look at what we're trying to prove. We're actually trying to prove that 4 and 6 are supplementary. So we want to know that these 2 are supplementary. One of the things that we know about angle 3 and 4 and 5 and 6, like respectively, is that they're both vertical angles. So I'm pretty sure that's going to play a part in proving that 4 and 6 are also supplementary as well. So let's go ahead and let's state that information. So the measure of angle 3 is equal to the measure of angle 4, and the measure of angle 5 is equal to the measure of angle 6. And that is your vertical angles congruence theorem. Whoops. VACT, vertical angles congruence theorem. I'm not going to write it out. Okay. The next thing that we want to say is, hey, this 3 and 5, because they're supplementary, they add up to 360 degrees. Now that we know that 3 and 4 equal each other, now that we know 5 and 6 equal each other, we're going to go in and we're going to be able to replace in our equation of 3 plus 5 equals 180 degrees with the 4 and 6. Here's what I mean. So I can say the measure of angle 3 plus the measure of angle 5 is equal to 180. And that's just the definition of supplementary angles, right? So here's my definition of supplementary angles. Then I can go in and replace 3 with 4, 5 with 6. And that's how I can go in and say that the measure of angle 4 plus the measure of angle 6 also happens to equal 180 degrees. And that's my substitution property of just property. I keep saying property of equality because I'm so used to saying property of equality, but this is just property. Once I know that 4 and 6 add up to 180 degrees, I can then go in and say angle 4 is supplementary to angle 6. Not measured, just regular angle 6. And that's going to be my definition of supplementary angles. That looks like a weird way to write definition, but okay, whatever. I'm over it. All right, and the reason why we need to go in from this to this using that definition is because we went from this point of 3 and 5 are supplementary to 3 and 5 add up to 180. It's that same definition. We're just working backwards and forwards in both cases. Okay, let's go ahead and let's take a look at the last problem. We have AFC and EFC are the same. So AFC is this one, EFC is this one. We know that they're equal. So that's going to be the very first thing that we write down. Measure of AFC is equal to measure of angle, EFC, and that's given information. Okay. The next thing that we would want to say is that probably from the information that I'm given in here, knowing that I'm going to have to prove something with numbers, I'm going to probably want to say that 1 plus 2 equals this AFC and 3 plus 4 equals this EFC. So again, I'm going to use this as like 2 lines, but the reasoning is going to be the same. So I'm going to actually change this. Oops. Okay. So the measure of angle AFC is equal to the measure of angle 1 plus the measure of angle 2. And the measure of angle EFC is equal to the measure of angle 3 plus the measure of angle 4. And if you didn't guess already, it is the angle addition postulate because that's what happened. Whoops. Sorry, it is the angle addition postulate because that's what happens when you take 2 pieces of an angle and it equals the whole angle together. Okay. Then let's go back to the next piece of information that we're given. So we are told that FC bisects BFD. So BFD is right here, this angle 2 and 3, and FC is the bisector. So actually, these angles 2 and 3 are also the same. They're also equal to each other. Okay. So what does that mean? So the first thing that we're going to do is ray FC bisects angle BFD, and that's given information. We're then going to go in and we're going to state that angle, measure of angle BFC is equal to measure of angle DFC, DFC, and that's my definition of an angle bisector. Bisector. We're going to go in and we're going to say that certain pieces of information are the same angles. So this next set of information will also be the same. So the measure of BFC is actually the measure of angle 2, and the measure of angle DFC is the measure of angle 3. And that's just information that's given by the diagram. Given by diagram. I've seen that in a few schools in the area where teachers give that piece as like a totally acceptable, like, well, it's in the diagram, so I know that this angle is actually angle 2. It's just a different name for it. Don't think that you're going to get away with like, oh, obviously they're the same angle because they look the same. That's not going to fly with given by the diagram as a reason. But when you see an angle and it's just a different name, like it's a numbered angle versus 3 letters for the angle, that you can totally interchange. Okay. And then we're going to go through and we're going to say, hey, I can actually say that 2 and 3 are the same because I know that these two angles are the same, so I'm just gonna replace these two with those two. So I can say that the measure of angle 2 is equal to the measure of angle 3, and that's my substitution property. So I'm actually substituting 2 angles for another 2 angles. If I feel like I'm writing sideways. The next thing that I can say is, hey, I know that these two are the same. I also know that these two can be replaced with these. So let's go ahead and let's do measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 4. And that as well is my substitution property. And then I can go in and actually subtract 2 and 3 because I know they're equal to each other, right? So I can go in and say measure of angle 1 equals measure of angle 4, and that's going to be my subtraction property. That's subtraction code. And there you have it, 7 angle proofs, all in a little bit of time, I hope. And this is going to be really great practice going through this set of problems so that you can actually get a better understanding of how to solve these problems. The more you do, the better you become, okay? And I will see you in a later video. Bye.